So what I want to do is I want to walk through descriptive statistics for you, what they are, first of all, and how to report them out in an effective way for business. So one of the things I hate is a really long video, so I'm breaking this up into 4 parts. And so those 4 parts would be looking at, first of all, data and measurement, which is this part. The next part would be the descriptive statistics themselves, the third part being data visualization, and then the last part being how to write this up, how to actually report it out. And so one of the things I'm going to say here is, as part of this presentation, is that what you don't want is what's on the screen right now. You don't want a mess. And one of the things is that it's easy to create a mess with this kind of stuff. But if you stop and learn some basic techniques and some basic information, you can begin to kind of frame this in a narrative where you paint a picture of the data, and the data actually looks much better than what we have here on the screen. The last thing is, before we get going, is I know that some of you may have had a stats course before, and so that this would be review. And I remember being a graduate student and being in every advanced statistics course that I was ever in, someone covered descriptive statistics, and I'm like, why? I know this. I've been over this 100 times. So one of the things that I know from being an instructor is that for some of you, this is the first time you've seen this material, and I get that. And so I want to make sure we walk through it. For those of you who had it before, one of the things I'm going to suggest to you is that this may be the first time you've seen the material presented in this way. And so I take a different approach to stats than a lot of statisticians. I take a very practical approach to it. For me, it is not about the math. It is about what it means. And so that's going to be the focus of where we're going with this. All right. With that said, there are 2 basic pieces to statistics. If you look at any stats book, it'll say this. The descriptive stuff is what we're going to talk about today. These are just the raw numbers. And to be honest with you, in the professional world, in the real world, this is all you get. And this is usually where people stop. Absolutely. Inferential is much more powerful and is what we're going to do mostly in this course. But I want to make sure that you know that what you're going to do is you're going to step well beyond those descriptive statistics and really kind of learn how to make decisions with data. This is a very traditional slide, and I'll explain it in a minute, but I want to make sure that you know that it exemplifies the things that differ how I approach statistics than how a mathematician approaches statistics. To be honest with you, I don't care about this at all. It is important, and to be very honest, it is an important mathematical problem. For business, it's really not that important. And so here's why. In business, we very seldom examine an entire population. We always take samples. So everything's a sample, and it really doesn't matter. Now, here's the thing. For a mathematician, this is really important, right? This is mathematics, right? This is how mathematics works. And so a mathematician wants to spend hours explaining this to you. I'm going to look at you and say, yeah, we're always going to use a sample. Don't worry about populations. Boom, we're done. With that said, I should tell you that by definition, the population is, if we took every student at Carroll University and we looked at them as a population, that would be the population. We have them all. If we take a subset of them, that's a sample. We always work with samples. It's just how we work. Thing is, within a sample, everyone needs to have the opportunity to be sampled, and a random sample is the most powerful sample that you can have. And so what you want to do is you want to randomize the sample. The other thing I'm going to tell you is that all your results in this class are fraught with error. If you think you're going to get an exact answer to something, you are sorely mistaken. You are going to have to think about error. And that error might be due to measurement. It might be due to the fact that your sample isn't really random. It might be due to all kinds of things. But error is part of what we do. And there's no way you're going to eliminate it, but you can quantify it and you can talk about it in some different ways, and we'll do that. But I want to make sure that you know that that's going to be the case. The other thing is, and I'm going to show you formulas periodically in these videos, mainly to let you know that I'm not making this stuff up, that there are real formulas to this, but also so that you have a sense that what we're doing is we're trying to derive meaning. We're not really thinking about the formulas. Mathematicians are interested in the formulas. They're interested in how they're derived. They're interested in how they work. We're interested in what they tell us. All right. There are all kinds of statistical symbols and things like that. So one of the things about statistics is that it's a science that is based on small data sets. And we're going to use some small data sets to kind of get at some things, because we're going to define questions pretty tightly. But I want you to know that there are a lot of big data sets out there, and these are some of the places you can find interesting and good data sets. We're going to use some of these in this class. Your first assignment is probably going to be with IPMs, and so we'll be working with big data sets a lot. There are lots of places to go look for data. Places have data portals. The data is usually free. We have some proprietary data that you can use from Esri that's not free, but it's free to us more or less, and I'll be showing you that as well. I want you to think about some different kinds of data. And so, I'm going to use the phrase continuous data, and I'm going to use data reference to discrete data. And discrete means that it exists in some places and not in others. In other words, it's not there all the time, whereas continuous data has a real flow to it. It could be any number. And so discrete and continuous data will play a role in this. So, for instance, you may have data that exists in Milwaukee but not in Chicago, and things like that. So, I will be using these terms a lot: nominal, ordinal, interval, and ratio. And what I want you to think about with these is that these represent different kinds of data, and you can do different things with them. And so in thinking about these, what I always want to make sure that you're looking at is, do you know which kind of data you have? And it often goes by different names. So when I learned this, we called it Stevens' power law, but it deals with different kinds of data. So nominal data has no numeric value. It simply counts of things. It's qualitative data. So later on this term, you're going to be using some statistical tests to look at nominal data, but not right now. Ordinal data ranks things. So if you deal with ranks, that's dealing with ordinal data. There are some statistical tests that deal with ranked data, and that's an important piece. There are data sets that have arbitrary zeros. That's interval data. So if you think about arbitrary zeros, you can think about temperature and things like that. And ratio data, which could be any kind of regular measurement with a real and meaningful zero. We'll look at some examples of these. So nominal data. Data is qualitatively different from one another. Michigan's different from Wisconsin. Zip codes, census tracts, place names, student ID numbers. You can't do any mathematical functions other than counting how many of these things occur. When we're looking at data, and this particular table comes from Tableau, the data columns that are highlighted are nominal data. And the nice thing about Tableau is that it will label them ABC. In SPSS, they'll label them as string. String is another name. Text is another name. I think Excel uses text to call out what kind of data it is. Ordinal data is ranked highest to lowest. In this case, I've got a ranked table of counties in Wisconsin. You can add and subtract these. I like to use ordinal data a lot of times in HR pieces where I'm trying to rank candidates. It usually allows us to begin to think about these things more effectively. Also in consumer preferences, we use it a lot. So if you were trying to figure out which frozen custard is the favorite, you could figure that out by using ordinal data. You could give people a list of custards and begin to find that. Interval data has an arbitrary 0. And if you note that in centigrade, 0 is freezing. In Fahrenheit, 0 is much colder. You can add and subtract with this. Years also work like this, and so if you think about fall 2020, and I didn't update this slide, I apologize for that, but that was a different year for different communities. Ratio data has a real and meaningful 0, and you can do any mathematical functions, and oftentimes, particularly in statistics, we use ratio data, so you're going to see this a lot. And for scales of measurement, just so you kind of have a sense about this, ratio data, has a meaningful 0, measurable difference, a true 0 point. Interval data does not. You can read the rest of the chart yourself, but know that that's how this works. All right, so that's the end of this first part. Coming up is describing data through descriptive statistics.